into this, but we should be able to do this now. I asked you guys, and if you didn't, you didn't, but you still have to do it. Hypothesis. Vinegar. It says 5% on the jug of vinegar. What's the molar concentration? Did somebody calculate that? No, it isn't 1.2. 0.8. You got 2 decimals or 2 significant digits. So just, I know 0.8 is as accurate as 5% is. That anybody else can verify what Austin? I know it's not 1.2, but Austin is 0.8 moles, believe me. Anybody else? 0.8. 8 what? Incidentally. 4? Or no? 8.2? Yeah. Just incidentally. But I'm going to put 0.8 because significant digits wise, that definitely says 5%. So yeah, that's the perfect answer. Okay, but I need the calculation. I will be looking for that one. Now the next thing. Now this is based on last year, last semester's group. So just hang on. Not everything's the same. Get rid of those. That's why I do it in a different color. So don't copy everything. Okay, your materials are vinegar. And I wrote down, and I weighed this out yesterday. I actually did it during calculus, or was it just after calculus? It was just after calculus. 40.84. Grams. So that's what you definitely need. It changes from semester to semester because it's just whatever I scoop up. You think, yeah, it's ballpark. But you need the exact concentration of sodium hydroxide. Now, I'll read the words because it's handwritten. So, vinegar, I think you read. The NaOH has this concentration. That's very important. Make sure this is there. Burette is this word. That's the graduated cylinder type thing. I showed you the other day. Now, right? The burette cloud allows phenolphthalein, labeled clearly as phenolphthalein. And put these in the center because that's my color indicator. Beakers. Wow. I'm going to set on some beakers. Boy, it's so I'll set up beakers over on this side just so it's not congested over here. Grad cylinder. Graduated cylinders are over here. Now, I'm going to ask you guys to measure, I'll just take a look. Now, I'm going to ask you guys to measure out 10 mils of vinegar, I think. So these little guys should do the trick. So you know where they are, right? That's what I'm kind of doing. Did you recall that the lab stands are in this drawer, but you have to assemble them. You got to mix and match until you find a rod that this one does first try. There you go. Wow. Anyways, so that's what these are, right? And the burette clamps are in the box that I set over by the lab stand drawer. Okay. Now, this group already has it. Okay. There's your materials. Now, what are we going to do? And I demonstrated the other day how that works, right? But safety. We're going to wear glasses. Use caution with the sodium hydroxide. The vinegar, you use it as a kid, so I don't think you ever worry about it. You know that it would hurt your eyes. Use common sense. But where did my glass? If you don't wear prescription glasses, if you have prescription glasses on, like Austin and myself, you're fine. So, anyways, it's important. Wash your hands, obviously, too. Sodium hydroxide, it causes skin irritation. It won't eat through your skin. I wouldn't use it. Now, here's what, and if you want, don't worry about copying this out right now, but I'll leave this up. Measure approximately 10 mils of vinegar. Now, there's a 10 mil grad cylinder. So it could be just under 9.5, 9 point, whatever. That's why I'm saying approximately 10 mil. As long as you write down exactly what it is. Okay? 8.7. Fine. You don't want to go over because there's no margin past 10. Okay? Everybody understands that? Don't go over 10 to the and you should be able to actually use the measurement 9.8 or whatever, 0, if you think it's right on. 9.8, 9.85, if you think it's just a touch over. Oh, I said the one decimal place is a different group. Okay, let's go to one decimal, 9.8, whatever, 8.7. Why is it getting closer to 10? The 8s are not, it's fine. You're going to add 2 or 3 drops of phenolphthalein. You saw me do that into the vinegar. And that's where you use these little beakers. Fill the burette with sodium hydroxide to approximately 20 mils. You're not going to need a lot. You'll see the markings on there. You record the volume. Now, don't try to get 20.0. It's a waste of time. You're going to go like 21.4, 19.8. I don't care. That's approximate because you're going to write it down. It's done by subtraction. Record that volume. I'm reading through this more for video reasons. Add sodium hydroxide with the burette, the tap, until pink color stays. Record that final volume. You're going to slow down when it gets close to pink. And then stop. You're going to have 3 trials in total. Repeat 2 times. The first time will take longer because you're not sure how much, and I'm not sure either to not use this concentration. Exactly. So I'm not even sure what it is. Here's your chart that you're going to have. So, recording-wise, after that, I'm just going to see there's nothing else that we need to record. I'm going to just put it here so you can see everything. I'll pause the recording. Should be good. Okay, we have done our data, and a lot of people were getting their sodium hydroxide used as 22.7, things in that range, okay? But that's going to vary from group to group. I'm going to just zip through some things for the recording, but you're going to calculate a few things at a time. First thing is you need a reaction. This is vinegar, acetic acid, plus sodium hydroxide. You need the equation. Because you need the balance of the acid, balance of the base. First of all, now we have a different concentration. You've got to figure out what your concentration of the base is. And I think this here was, what did that beaker say? 40 decimal 4 into 40 decimal 84 grams of sodium hydroxide in 2 liters. That means you need to get moles. Now, this is a different set of calculations entirely, but you've got to convert to moles of sodium hydroxide. And then divide by liters to get a concentration. You need the concentration of the base, and that's how you get it. We're trying to find the concentration of the acid, but you're going to calculate, I said 5 trials, that was a different year. You're going to have 3 trials. Calculate the concentration of the acid. Because you've got volume of sodium hydroxide, that's the base. You got the volume of the acid. And you have the concentration of the base is the same for all. So you're going to calculate that 3 times using the BB, BA, CA equals BA, BB, C. I might have said it wrong, but the titration. You're going to find the average value of those 3 trials this year. And then you're going to calculate a percent error and compare it to your hypothesis concentration of the acid. On that, percent error is the mean value that you calculated minus the expected value, which is the hypothesis. Divided by the expected value times 100. In your write-up, you'll discuss error. And there's a lot of error today, and that's fine. That's why I wanted you to do this. And mistakes in your data and in your conclusion. That's what you're going to discuss. Discuss error and mistakes in your data, in your conclusion. Discussing mistakes. If you had a coded variance, I'll stop the recording.